Okay, people, here we are. We're going to do a few homework problems, right? To try and get through some of the ones you're having a little more difficulty with, particularly the word problems. Nobody likes word problems. We're going to like them, okay? They're going to be nice. But before we do that, I wanted to give a little review on this PIMDAS because that's really pretty important when it comes to all the problems that we run. Okay, so let's just a little review on PEMDAS, right? PEMDAS. Um, Please excuse my dear Aunt Sally. That's the the thing to help us remember it. But the bottom line is parentheses are first always. Oh, and inside the parentheses, the rest of this applies. MDOS, right? The rest of it applies. So whatever's in the parentheses and exponents, which we haven't done anything with yet. Then we have, this is key. This is really important to remember that then it is multiplication and division in the order that it's given, right? You don't run through and do all the multiplication first and then come back and do the division. You do multiplication and division in the order that it's in, okay? Left to right, okay? And then finally, it's addition and subtraction, okay? Same thing. You don't go do all the addition first and then the subtraction. You do the addition and subtraction, whatever comes first, in the order that it's given, left to right. So that's important. So multiplication and division, addition and subtraction. I'm gonna go over one thing that may help a little bit with this too. This isn't just some kind of random thing, this PIMDAS. It's there's rhyme and reason to it, right? And the idea is this thing called terms, right? There's things we're not gonna. I'm just gonna briefly do this. Something called a term, right? A term in math. Okay, a term is a single number by itself, right? 12. That's a term, right? 16 is a term, okay? And basically, terms are separated by addition and subtraction, okay? They're not separated by multiplication and division, okay? But addition and subtraction will separate terms. So I can have a 3 plus 4, and I have two terms in this equation, right? 3 plus 4 equals 7. So there's one term, there's another term. I can also have 3 plus 2 times 2, okay? And this, because it's multiplication, this whole thing is a single term. There are not two terms in here. This whole thing is a single term, okay? So you still have 1, 2 terms. And oh, by the way, that's 4, isn't it? That equals 7. So there's something to remember here, okay? That terms are separated by addition and subtraction signs. And in parentheses, again, so this particular parentheses, there's one term only, okay? Not 2 times 2, right? There's one term. It's 2 times, okay? Because multiplication, division they're shortcuts for addition, subtraction, that kind of thing, okay? And so that's something key to remember in terms of terms and PEMDAS. Okay, and we're going to see a little bit of that as we go through some of these problems. First one I want to look at, and most everybody did real well, but there's some things that are easily. Boy, my eyes are all shut. Oh, no, that's better. See, if I hold it up like that, then I guess I got an overhang here that blocks the whatever. So anyway, so we're gonna look at some. Would that be deep set eyes? I wonder if it's deeper than. Anyway, sorry. Anyhow, so we're gonna look at some mistakes that we make are really it has to do somewhat with PIMDAS. Some of it's a little bit of carelessness because we transpose numbers or something like that. I mean, some of these things get kind of long. I'll show you where some of them should be shorter than because there's different roads that we can take to the same point. And we like taking the shortest road, right? Anyway, so let's start with this one, okay? It is 3.35E, okay? 3.35E. And I'm going to write it up here on the board. By the way, this entire thing, interesting enough, is one term. It's all multiplication and division, right? So we start with 7/8 divided by 35 over 48. Okay? Don't mind my dog. We multiply that by 6 over 7. And then we're divided by 36 over, what is that, 70? 36 over 70. And then we divide by 2/3, right? 2 over 3. There's all division and multiplication, every bit of it, 100%, okay? So we just do left to right. That's all we're going to do, left to right, okay? Now, important thing here is, and some of you like to do this, and which is good, and some don't, which, you know, kind of makes big numbers that we have to deal with, okay? So let's take a look. So we start with 7/8. We know from our rules of dividing fractions, right, that we invert this one and multiply. That makes it a little easier, right? 7/8 times 48 over 35. Well, because of that, we can take and we can reduce, right? We can reduce, right? So 8 goes into both of these. 8 divided by 8 is 1. 48 divided by 8 is 6. And same thing here, right? 7 goes into both, right? So 7 divided by 7 is 1. 35 divided by 7 is 5. So what we end up with, this is just 1. 1 over 1 is 1. 1 over 1 is 1. It's 1. So we don't care. Anything by times 1 is that thing. So what we have here is 6/5. And we multiply it by 6/7, right? That's what it is. 6 over 7. That's the next one right there, okay? That's the answer to this. Bring it down. Multiply it by this, right? Well, 6 times 6 is 36. And 5 times 7 is 35, right? So we did that. We bring this down now. We do the inverse here. We multiply 70 over 36. This is so convenient. So if you reduce it, you don't have to deal with the big numbers, right? So in multiplication, not addition, subtraction, but here you can cross-reduce. 35 goes into 70 twice and in itself once, right? So that becomes 2. 36, well, that's 1 over 1, right? 36 over 36, 1 over 1, same thing. It's identical, okay? So it's just 1. So we end up here with just simply 2, right? So now we take 2 over 1 and we multiply it by 2/3, 3 over 2, right? And what do we end up with? Simple. 6 over 2. 6 divided by 2 equals 3. Right? That's the answer. That's it. That's it. And that is 3.35E. Right? I'm just going to make sure that was the right one. Yes, that's it. 3.35E. That's what it is. Let me put the note up here. And then let's move on to the next one. Okay? So that's it's pretty straightforward. It's not bad, right? Okay, hopefully you didn't suffer with it too much. I think most people did okay, but I just want to make sure, you know, so because sometimes people will do this first. Multiplication, I got to do first PEMDAS. No. Left to right, multiplication and division in the order it's given. Very important, okay? Now, let's go on to the next one. Gets more interesting as we go along, okay? But you'll see that these aren't too bad. You know what? I know, it's true. Watching someone else do a word problem is always easier than when you go at it yourself, okay? I get it, right? But it gets easier, right? With practice. So even though I give you certain homework problems to do, remember to do them all. But don't turn them all in because I don't want to wade through it all. I'll give you specific ones to turn in. But do all the problems. The difficulty is that, you know, you can check it against the book, right, in the back. Sometimes their answers aren't always correct. Just giving you a little hint, and we'll go over one that we'll see that that's the case, and it's a PEMDAS. So let's take a look at the next one. I don't want to make the videos too long because, well, then they're too long, right? So let's see what we got here. No. Let's see. What is this? Yeah, we did that one. What's this? Oh. Yeah. Well, let's make sure here. I don't want to waste your time on the video. Okay, here we go. So I guess I decided to do, I think it was 3.37. which is pretty, not too bad once you see it, right? No, 3.36 first. Okay, we're going to do that one first. Okay, 3.46, excuse me. No, 3.36. Wait, where is it? Hold on a second. Sorry. No, 3.37. Here it is. Okay, so here we go. This is what we have, okay? 3.37. Let me read the problem. This is a word problem, right? Okay, a special non-ferrous alloy is composed of 5/12 of tin, 1/3 copper, and 1/4 zinc. Okay, so this alloy, that's what it's made of. How many pounds of each metal will be used to pour a casting that weighs 224 pounds? So what's given, right? It's good to know what's given, right? So the total poundage is 224. 224 pounds. And we've got 5/12 tin. 5/12 of that 224 pounds is tin, right? And then the next one is 1/3 will be copper. And then we have 1/4 that will be zinc. And that's our alloy, okay? That's our alloy. Special alloy. The question is, I know how many pounds there are, and of this, I know that there's 5/12 of the alloy, and actually it's irregardless of the poundage. Whatever the poundage is, 5/12 will be tin, 1/3 is copper, 1/4 is zinc, okay? But I've got 224 pounds, and I need to know the poundage of each, right? If I'm going to have 224 pounds of this alloy, well, how much of each metal do I need? How much do I need to melt together and make this alloy? Okay, that's the question, right? Well, let's see. So what is this? Is this a multiplication? Well, I'm going to tell you there's a few trick words, right, that we look for to tell us what it is. And the word of is a key word for word problems, right? Of. That almost always, in fact, I can't think of a case, means multiplication, okay? When you see of, that's a good sign that you're going to have to multiply, okay? And then you're going to get how many pounds of each metal will be used to pour a casting. Special non-ferrous alloys is composed of 5/12 tin, etc. Okay, so it's multiplication. So I'm going to take this 224 pounds, and I'm going to multiply it by each one of these numbers to get what I want, right? Of each, right? It's relatively simple, right? So we have 224. Now remember, any number all by itself, even a fraction, can be placed over 1 to say that's how many, right? And it's the same number. It doesn't change the number. It doesn't change the value. So remember, you can change this into a fraction simply by going 1, right? Now, if I'm going to multiply, then I start with 10 times 5/12, right? Times 5. That's my problem right there. That's it for 10, okay? It's going to be the same thing for copper, and it's going to be the same thing for zinc. All right? So let's start with 10, right? We don't see twelfths of anything very much. We'll see thirds and fourths, but 12s, right? And 5/12 of all things, right? Not 6, a little less than half, right? All right, so what we do is multiply. Now, I can take this and multiply it straight out and get a big number over here, but maybe 12 goes into 224. But how do I check? Let me check. If it goes in evenly, then I'm just going to, do something. Maybe 6 is a better number. I don't know. Let's just see. In fact, I know one thing's for sure. 2 will go into both of them, right? 2 will go into both. So let's do 2, right? If we divide by 2, let's start with 2, right? 2. So there's 1, 2, 112. So this would be 112 over 6, but I could divide it again by 2. So 4 is probably a better number. 2 times 2 is 4. So 4. 4 goes into 20, right? 5 times. And that leaves me with 2. And if I bring down the 4, it goes into 24. Well, it goes into 24. What is that? 6 times, right? So 56. So I'm looking at this number 56, right? So what I have then is if I divide by 4, I get 56. Don't get confused. You know the answers over here. This just happens to be 56. 12 divided by 4 is 3. Okay, so we're already starting now with a smaller number, so that's better. Now, I take 56 times 5, okay, because I'm just going to multiply it across now. There's 30, 28, 208. So that's 280 over 3. Now, I'm suspecting I probably could have divided by 3 also and taken it down one more notch. But let's just do this, and we'll be okay. So we have 280 over 3. Maybe not, actually, I think about it. So we got 280 divided by 3. That's what we're looking at. So 3 goes into 28. Let's see, 9 times 3 is 27, right? So there's 9. And there's 27, and we bring down the 1. 28 minus 27, 1. There's 10 goes to 3, and 3 goes into 10 3 times. And what's the balance? That's 9. That's 1. 93 and a third. Bam! There it is. 93 and a third. Okay, 93 and a third pounds of tin. Right? That's it. No, there's no more multiplication. You're done. Okay. 93 and a third pounds of tin. Now we're just talking plain English, right? But that's that one. You do the same thing for the copper. You do the same thing for the zinc. Okay. And that's what you get. Okay. I'm going to let you guys work that. I think most people actually did pretty well on this, but if not, maybe this will help you to get there. Okay. For those that did not. Okay. Let's go on to the next one. Let's see, that was 3.38. You know, again, most people did okay on this, but some struggled a little bit. And again, it's a word problem. You get it. And you notice that finally, when we set up the word problem, right, that the rest of it, most of the work's just in the math. That's all it is. So now let's do this next one. Pipe fitting. Here, let's read it. I'll read it. A pipe fitting weighs 2/3 of a pound. Okay. How many fittings are in a box weighing 122 pounds? I've got this box full of pipe fittings. The whole box, everything weighs 122 pounds. Each pipe fitting weighs only 2/3 of a pound. Okay. But the box itself, right, weighs 32 pounds. That's all the information I need. So what I want to do is I have a 122-pound box, and I want to eliminate the weight of the box first thing, right? So we take 122 minus 32, right? There's 0. 12 minus 3 is 9, okay? So the remaining weight of just the pipe fittings now, my dog, someone comes to the door, they get so dang excited. It's just, But that's what it is. Nice dog, right? Likes people. Well, I won't tell you, bad guy could come, he'd probably lick him to death. But whatever, you've probably heard that term before. Anyway, so ignore the dog. So we have just pipe fittings is 90 pounds. That's it. Just the pipe fittings. Each pipe fitting is 2/3 of a pound, right? That's what it is, 2/3 of a pound, right? So the pipe fitting themselves, each one is 2/3 of a pound, right? Now this would be really easy if it was just 1 pound. Each pipe fitting was 1 pound, right? And there's 90 of them, so 90 pounds, so it must be 90 pipe fittings. But it's less than a pound each one. So you got to think that it's going to be more than 90, right? It's going to be more, 2/3, right? Now, so what is this again? Is this a division? Is it multiplication? So what are we going to do here to, get the answer, right? Division, multiplication, what, right? Well, so here's what it is. When you have a problem like this, and you have X amount, and you know what 1 is, and you need to know the total, you take this number here. So how do we get 1 if they were 1 pound each? Well, it would be 90 divided by 1. Oh, that's 90, right? Then that would be 90 pipe fittings. Okay, so it looks like a division problem. Well, you could say, well, I could multiply by 1 and still get the same number, right? Yeah, that's true. But let's say it was 2 pounds each, right? Let's say there were 2 pounds, right? And you said 90. It weighs 90, but each one is 2 pounds. Well, if you multiply about 90 times 2, you get 180. No. And if each one, if you didn't took it like 180 times 2 pounds, you get 360. No, it's wrong direction, right? So it's division, right? So it's division. So we take 90 and we divide it by 2/3, okay? That may seem counterintuitive, okay, at first, but you end up getting used to it, that you divide to get the quantity, right? Yeah, that's what it is. So, and it's interesting. Whenever you divide by a smaller number than 1, your resultant is bigger. It's a bigger number, right? That's what it is. 90 divided by 2. Well, let's say 90 over 1. So then we say 90 over 1 times, because you invert it, 3 over 2. Well, I can shoot that down to 45, right? And then this down to 1. And now it's just 45 times 3. We're done, 1 times 1 is that. 45 times 3. So let's see. 45 times 3. 5 times 3 is 15. 3 times 3, 12, 13. 135. That's how many fittings are in that box weighing 122 pounds. The box is 32 pounds, so the fittings themselves total weigh 90 pounds. And because each fitting is 2/3 of a pound, not a pound, there's actually 135. Well, we can kind of prove this out, right? Let's see if we can prove it. Let's take a look, right? So if I multiply 135 times 2/3, when you ever multiply a number by a fraction, or let's say a number that's smaller than 1, take a number, multiply it by a number smaller than 1, okay? And then in that case, you are going to get a smaller number. So watch this, right? So we'll take 135 and multiply it by 2/3, right? Let's see, 135 over 1 times 2/3. Not division, so just leave it like it is. That's it. Okay? Yeah, now I'm curious. It's possible that 3 goes in there. Let me make it easy. I'm showing you this because sometimes it's obvious, sometimes it's not, but just check it out, right? So 3 goes in there 4 times. I bet it is. Okay. And that leaves you with 12. Bring down to 15. You get 45. Okay, so this goes to 1. This is 45. Right? And by the way, what we're finding now is how much does 135 fittings weigh if they're 2/3 of a pound each? Now, guess what? It's 45 times 2 is 90. Over 1, that's just 1. So it's 90 pounds. So that's our check. We checked it. It's correct. Okay? 90 pounds. Okay, so 135 fittings is the answer right here. Here it is all hidden, right? 135 fittings. Okay, so it was a division problem. Okay, and so think about it. Sometimes it's a little counterintuitive that I divide to get the whole quantity. Okay, but remember that you do the same thing with money, right? To get the whole quantity, it's a division problem. So whatever it is, we started with 190 pounds. Okay, and we divide it by 2/3 and we get the total quantity. Your brain will start to wrap around it as you continue to do problems like this. Just remember the rule, okay? Okay, so this was division. Let's go on another one, but I'm going to stop these videos. Sometimes they're too long. It's a pain to upload. So we're going to stop this one and go to and make a new video.